words here? Well, I put it through a workflow process which looks at it and says, I can take every bad word and put asterisks on there and resubmit it back, and now it is approved. And so instead, I see asterisks everywhere. That's fixing the problem, not airing it out. That's the workflow event pattern of reactive architecture. And so there's a lot of opportunities that we have. If I can't fix it, then I'm going to send it over to a human to review it and maybe to kind of analyze it. So there's a lot of opportunities here that exist. But what happens if I need to get the name? I think we have a question here, and then I'll show you what happens if I do need a name. Oh, is that the question? I love that. Okay, great. So the question is, yeah, but what if I need the name? Yeah, so I can still use messaging, and it's called request reply. So let's say that I am the wish list, and I need the demographics, get the name. Can I still use messaging? Well, absolutely. It's called pseudo-synchronous. Instead of a message channel, what I have is a request queue that I'm going to make the request over to a queue to say, I would like the name of customer 123. And then you're going to give me that name and a reply to coming back. And so here's how it works. Now watch this animation. It goes kind of fast. All right, ready? Here's what happens. It's asynchronous messaging. So what I do is this. I send a message to a queue, and I come back to my control right here. In other words, that's a send in messaging. This is just a send. And it immediately comes back and says, yep, it's in the queue. Now, what happens is this. Watch, this is going to process, and I can do some processing right here. But eventually, I have to do a blocking wait, and I'm waiting for that reply to come in. And so this is like a next delivery, or a next delivery in RabbitMQ, or a receive in JMS. And so what I'm doing is I'm blocking and waiting for my message to come back. And so anyways, request reply processing, this was the very first lesson I posted in developer-to-architect.com/lessons. If you go there, this is something that I talked about yesterday. That's a website I kind of developed just as give back kind of thing for this journey from developer to architect. It's a hard journey. And so in there, every Monday, I post free lessons in software architecture. And so that shows you the actual mechanisms. And you can see a video. It's got all these slides about how to actually do that. But that'll save us about 10 minutes of time.
So this pattern, request reply pattern, it is still faster than that synchronous REST call through the API gateway also.
Yes, and I'm glad you asked that question. Yes, even though I'm doing request reply, my latency is what? As a matter of fact, boy, are you, I thought that was the very next slide. I was like, are you looking at my slides? Because that's the next thing I'm going to cover. Okay, so is it still faster? Hold on 1 second, because I'm going to show you that. But also, something I cannot do in REST is now I can broadcast things to you. If I need to talk to multiple services to tell you to do things in parallel, I can now use publish and subscribe or pub/sub messaging with topics or topic exchanges or fan-out exchanges to be able to send a message, fire and forget, and have all of you subscribe to that to all receive it. Okay? So these are some of the capabilities. But let's get back to your question. Is it really faster? Okay, do you remember with REST, here's, oh, by the way, I'm so anxious to get to your question, I keep forgetting I've got other stuff to talk about. What about the 4 instances? Because I'm not going through an API. How do I do load balancing? I'm not talking to you. I'm talking to a queue. And so when I send the message to a queue right here, there it goes, all 4 instances are load balanced on that queue. Only one is going to receive the message. This is queuing as opposed to topics, pub/sub. And so with queues, all 4 instances of that demographic service there are all listening on that queue. The first available one to receive it is going to process that response and give me back the name through the reply channel. And again, go to lesson 1 on developer-to-architect.com, and that shows you exactly how to do this. But anyway, so the point is I'm bypassing the API, but I still have load balancing capabilities right here, which is really cool. Now I can finally, yes, now I can get to your question. Yeah, but I know messaging is async, but if you're doing request reply, is it really faster than REST? REST is 87 milliseconds, messaging is 92 in our environment. No. Or is it? Because watch this. Do you remember that RESTful call? There's 100 milliseconds. There's 200 milliseconds. Yeah, that's 200 milliseconds in latency. I'm not going through our entire topology infrastructure. I'm going to a broker, which takes also, let's say, 100 milliseconds round trip. So that is all I'm doing, is 100. So the answer is yes. If I'm going through, the answer is yes. Possibly. It will either be around the same or much faster, 2 to 3 to 4 times faster, depending on how many layers of API infrastructure I'm going through. Yeah, so this is where we really start tuning all these dials to really see why we're not performing or how to increase performance. Okay, so possibly, and let's be fair, possibly I can increase performance. But watch this. Do you remember this get customer data? That public endpoint that had 500K of information, 45 pieces of information about a customer, including your picture. I want the name. Do you remember it polluted this API? Well, am I going through the API? No. There's my endpoint, right there. Get name. And do you see, I can now create, and I'm going to put it in quotes because it's really not a private API, but it's not exposed to the public. So I can now start creating a private API. I avoid stamp coupling. I have efficiency in my bandwidth of my network, and I'm not polluting my API. It's one way of doing that. You know, if I avoid stamp coupling and I'm using REST, I'm going to pollute our API. It's going to become very confusing about what is public consumption and what is really meant for inter-service communication. It is very clear here. That's one of the main, this is probably the best feature of messaging, aside from all the broadcast and stuff between services, is this whole idea of managing API endpoints. But there's something else magical that happens here. Yeah? Yes. So when I say I'm polluting the API, so the point is, let's say I have, so the question is, but you say you're polluting the API here, but you still are having endpoints here. But they're not going through the public API, though. And so if I have 1,200 operations in our ecosystem, my API documentation shows 1,200 well-defined endpoints. But I have another 3,000 inter-service endpoint calls. They're not in the API now. They're all buried down here. And so what I want to do is steal your question to really point to, for every positive we talk about here, I am paying some price. And what's the price I'm paying here? I can use Swagger and other kinds of tools to well document my RESTful API endpoints. And it's very, very effective too. I know of no product in the world that will automatically be able to tell me what are all my endpoints for messaging. That's all custom code. I usually use code crawlers and stuff to do that, but that's all custom code. Let me show you a way in which, yes.
So here I see in system A,
Yep.
We are putting additional burden of managing the state.
Yeah.
How do we know when we request we get the replay? And that kind of state we have to manage in system A.
Yes, okay, so the problem here is I'm putting additional load on this, aren't I? Is that your question? On this guy?
No, on the system A, when we're making a request, how do we make sure we got the reply back? Because it's a pub-sub model, right?
Oh, yes. No, this is not pub-sub. This is queuing. So the point is, I see your question. The question is, let me go back here. Yes, that was the, let me go back quite a ways. That was this piece right here on request reply. In other words, how do I know I'm getting the right reply? How do I know I'm getting my name? Is that what you're asking? Yeah, so in this case, that's why I was kind of deferring you just because of the time to go to this website right here, my website, developer-to-architect.com lessons, and actually answer that question. But the question is going to take about 10 minutes to answer. And so if you watch the video here, I can actually move on to other material I don't have recorded. And so, it's using correlation IDs. Basically, I match a message ID here to a correlation ID. I do a blocking weight with a message selector based on a correlation ID. And that's how I know there's 25 names in that queue. Which one's mine? It's the fact that the correlation ID and my message ID match up. But the actual mechanisms of how to do that is in that first lesson in this thing. So yeah, sorry if I wasn't clear on.
Mark, one question. Here, front. Right in front. Here.
Oh, yeah.
So if we decide to go for the messaging kind of way, right? Are there any recommendation? How do I know how many queues I need to set up? What are the metrics?
Yeah, great.
What is the
I
load for that? Right?
I love these workshops. Oh. All right, so how many message queues? So let's get back to where we were here because we've got a couple more things to talk about messaging before our break. We've got 3 minutes. So let me answer your question and then talk about one more aspect of messaging, and then we'll move on to gRPC right after the break. So yes, how many kind of queues? This is why I like, first of all, a RabbitMQ in most microservices ecosystems, because if I'm going to rely on messaging to communicate to all of you, the problem is that if that goes down, then I can't communicate with anybody. And so I like highly reliable, highly available messaging. RabbitMQ, which is by Pivotal, actually, Pivotal bought them, actually supports this. RabbitMQ sits on top of the telecom platform, which is what telephone companies use for switching. It's highly, highly reliable, probably one of the most reliable platforms that we can have. RabbitMQ itself is written in Erlang, which is a message-based language. So we're writing a message broker in a message-based language. In other words, Erlang has messaging built into it through transactional memory and kind of an actor message model already built in. So very similar to Scala in that way. So it's written in Erlang. I have clusters of nodes and nodes of clusters. I can just continue to do all these clusters. So that's why I like RabbitMQ. But whether I'm using RabbitMQ or ActiveMQ, generally I will overwhelm a messaging infrastructure here. And so the point is, I generally have, and as a matter of fact, this is what I want to show you, is oh, I got so much to show. To answer this question, generally I will domain scope and use scope, use case scope, my brokers. I will have a broker cluster for customer communications. I'll have a broker cluster for all order domain communications. I'll have a broker cluster here for all shipping communications. I will have a broker cluster for eventual consistency over here. I'll have a broker cluster for broadcasting over here. So in other words, it's pretty rare to have a single cluster for all the messaging in there. And that's the way to take care of the fact that I've got 2,000 queues and 3,000 connections and it's not going to work. It's domain scoping those, yeah, and that's exactly it. But now, how many queues, though, is the question I'm so excited about. So, should it be 1 queue per service, 1 queue per endpoint? What should that be? Let me answer that question. And that has to do, you know what, it is the break time, and I want you to see your colleagues and stuff. 3:15, is that right, Usha? It is, and you know what, I don't want to go longer because I want you to be able to talk to your colleagues and stuff. So, because this is the part I really get excited about. So I'm going to hold off, and let's look at one last aspect of messaging right after we come back from the break on part 4, and then I'll show you gRPC, we'll look at gateways, and then the orchestration patterns and reporting, and then we'll move on to caching. So yeah, so let's take a 15-minute break, and I think we're going to meet back at 3:30. Is that right? Yeah, that clock, by the way, is 5 minutes fast, and so if you're wondering, you're not missing your colleagues, and so, yeah.
So we'll see you back in 15 minutes. We are doing a small video testimonial on this site, so I'll request you to please exit from those doors. We're doing a small video testimonial here. So.
Oh, that's right. We're going to do it here, right? Okay. Yeah, it's only going to take maybe about 5 minutes. Okay, yep. So, all right. So, oh, yeah, there you are.
So we can use those doors.
They can, Usha? Oh, they can watch it if they want. It's just we have to be quiet. Oh, okay. So, does everybody have to? I don't want to have make everybody leave. Oh, outside here. Oh, so you guys don't have to leave here, though, right? Oh, you guys don't have to leave. I mean, please, grab some coffee. But, okay, but we're doing it in here. Oh, okay. All right, great.
Okay, you can use these doors because we're doing it on the stage.